The chairman kindly made allusions to pulsars. Pulsars are incredibly accurate clocks. And through studying pulsars, we have been able to ascertain the masses of the planets in the solar system to something like 10 decimal places. Because we need to know how much the Earth is moving due to the masses, the gravity of the other planets. The pulsar people will tell you there's no such thing as a massive planet hiding the far side of the sun. The pulsar astronomers would have found it long, long ago. And also, and maybe slightly more alarming, the solar system is potentially chaotic. This means that the planets go round and 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 suddenly go whee! That's what chaos means in one sense. If you have a girt great stray planet like Nibiru, that's going to have destabilized the solar system. It'll have gone whee long ago. So we ain't here. So, if you suddenly see a bright light appearing behind the sun, tell somebody. But I don't think you will. Rather more seriously, could we have impacts by big asteroids? The asteroids are bits and pieces that are left over, basically, from the formation of the planets. This slide shows a montage of photographs of a number of them, and you can see they're definitely bits and pieces shaped. This slide's going to be hard to see further back, so I'll talk you through it. The sun is at the center, and the white lines are the orbits of planets, regular planets. And there's a whole load of dotted stuff around here, because the asteroids tend to cluster in a belt called the asteroid belt, which is fine as long as they stay there. But occasionally, one gets or two get perturbed, and for instance, there's an Apollo asteroid that can come on an orbit like this. It's shown in red, and you see it crosses the Earth's orbit. And there's a group called Amor asteroid that do an orbit like that, and also up here crosses the Earth's orbit. Now, just because something crosses the Earth's orbit doesn't mean there's going to be a collision. You've got to have both bodies on the same spot at the same time. And the odds are the Earth will be somewhere around here with the asteroids going through that point. But sooner or later, there could be a collision. So is this an issue? And is that what's going to happen in 2012? We do every so often see small asteroids hitting the Earth. They come into the Earth's atmosphere and they burn up, making a rather splendid fireball or meteor. And sometimes they split up into bits as they come in as well. But those normally burn up in the atmosphere. Even if they don't, you get a chunk of rock the size of a tennis ball landing on the Earth, and that's not a great problem. But there have occasionally been impacts by bigger things. This photograph shows a crater in the United States, variously known as Meteor Crater and the Barringer Crater. And we believe it was made by the impact of a body that was about 50 meters across. There. And you expect one of those every 100 years or so. To give you an idea of scale, this is a road coming in here. I'm not sure where it goes after that, but at least that gives you some idea of scale. And occasionally, even bigger things impact. This crater here has only recently been identified, partly because half of it's under the sea. And that was believed to be created by a body that was perhaps a kilometer in size, 65 million years ago. And this is the thing that might have been responsible for the extinction of the dinosaurs. So something the size of a kilometer landing might cause problems, even if it doesn't happen very often, every 50 to 100 million years. So is there something like that coming our way? There's now a lot of effort put into monitoring the sky for asteroids that might impact. This diagram is of a telescope in Hawaii that has just recently started functioning, and it's one of a number of telescopes that are watching the sky for meteors, amongst other things. They're looking out for objects bigger than 200 meters. That's 4 times the size of the Barringer crater's source. And things that come within 4.5 million miles of the Earth. To put that in context, the distance between the Sun and the Earth is best part of 100 million miles. So they're coming within the nearest 5% of the Earth-Sun distance. And they're monitoring about 1,000 objects. They keep watching them, they improve their estimate of the track of the asteroid, the orbit it's on, and they improve their estimate of whether or not it will impact actually, or just, go whistling past our ears. There is no known major impact in 2012. The next significant impact might be March 2880 by this object, still only faintly seen, called 1950 DA. But there's plenty of time to deal with it. Centuries to deal with it. And even with today's technology, we could deal with an incoming asteroid. Supposing we saw something coming in, bound to hit the Earth and big enough to cause problems. What we would do is we'd send up a rocket with a warhead on it, probably a nuclear warhead. We would not send it straight at the asteroid. We'd send it close past the asteroid. And supposing you're on the Earth and I'm the incoming asteroid, you send up a rocket with a warhead and you explode the warhead here. And that causes me to deviate. That's perfectly doable. It's a mistake to send the rocket straight at the asteroid because you merely break the asteroid up into 1 million pieces and then you've got 1 million pieces to track. So that's not such a good idea. The other thing we could do, even with today's technology, involves something called solar sailing. I don't know if you've heard of this. You send a rocket with a robot up to the asteroid, and the robot plants a sail, a mast and a sail with booms on the asteroid and ties down the sail so that it catches the solar wind and the solar radiation. And that will cause a small force, but significant, on the sail, and provided the sail's firmly planted, it will gradually cause the asteroid to accelerate away from the sun. And if you get your angles right, you could make it miss the Earth. Both those techniques we could do today if we had to. If this thing turns out to be really coming close, then we've got lots of time to improve the technology, and I'm sure we will. So I think we're pretty safe from asteroids. We've now got the monitoring in place, and we've got the ability to divert them. It could be expensive, but it would probably be a necessary expense, frankly. And I personally am not worried about that. I think it's under control. The third area is to do with galactic alignments, danger from the Milky Way. So I'll take just a minute or two talking about these. There's several variants on this, the way there is throughout this whole field. One is, we're going to fall into the black hole at the center of the galaxy, or into the dark rift. Well, falling into a black hole would not be a good idea. The dark rift is actually just some clouds of gas and dust. Falling into them wouldn't do anything. Or crossing the plane of the galaxy on the 21st of December will bring the danger of collisions. Yeah, right. We live in a galaxy which we call the Milky Way. If we could get outside it, it would look a bit like this. This is our neighboring galaxy, which is a bit like a twin of ours. It's called the Andromeda Galaxy. And it's about 100,000 million stars. And it's in a flat disk shape like a plate. If you look at the plate face on, you see it has a nice spiral pattern on it, a bit like a Catherine wheel. If you look at the plate edge on, you see it's thin. And if it's inclined at a bit of an angle between those two, you see it as this kind of elliptical shape. You can see hints of the spiral structure here. There's some dark arms, dark bands delineating the arms. And in the center, there's a hub of stars that are glowing very brightly. And, to be honest, also a black hole. We know there's a black hole in the center of our galaxy, and I'll demonstrate that to you shortly. If this was our galaxy, you see the spiral structure? It's spinning round like this. We're not at the center of it. We're out here, about 2/3 of the way out from the center. We're actually spinning around quite fast. We're doing over 200 kilometers a second. We're not aware of it, but we are. And in the lifetime of the galaxy, we've been round a couple of hundred times. And we've been in and out of spiral arms and in and out of the plane, and we're still here. So traveling around the galaxy doesn't seem to be a problem. We do it. We have done it. We're still here. Black hole at the center of the galaxy. Black hole is reckoned to be where this star shape is. This animation will run several times, and I'll let it run several times. Watch this yellow track. It's a beautiful, perfect ellipse. I don't know if you've learnt about Kepler's laws at school and the orbits of things. That is a wonderful classical orbit. And this thin green one is another one. Oh, it's very, very narrow, but it's orbiting. And something's making this green one go round a corner. You put together all the evidence from the way these stars are turning, and you're forced to the conclusion that about there is a very massive object that we can't see. Maybe 10 million times, 100 million times the mass of the sun. And we don't see it, even though it's that massive. So it's probably a black hole. So there likely is a black hole at the center of the galaxy. It's not very cheerful news, but it's a long way away. The black hole is 250,000 million miles away. For those of you who work with light years, that's 26,000 light years. Okay, so there's a black hole at the center of the galaxy. Does it affect us? Well, if we count the force of gravity from the sun as 100, sorry, let's read this. The force of gravity from the sun is 100,000 million times stronger than the force of gravity from that black hole. The sun wins. We stay with the sun. The black hole at the center can't grab us. Furthermore, if the black hole at the center of the galaxy did somehow grab us, and we started falling into the black hole at the center, and we started falling in at the speed of light, which is the fastest we can go, it would take us 26,000 years to get there. So we're not going to make that appointment on December the 21st, 2012. And I don't think we're going to fall into that black hole. Anyway. Alignments. Now, some of this you'll probably find hard to see. There's the outline of the galaxy and the black dot marking the black hole at the center. The red cross marking the position of our sun. And hugely exaggerated, the orbit of the Earth, which goes around like this. And In December of each year, the situation is the Earth is here, the Sun is there, and the black hole at the center of the galaxy is beyond the Sun. For those of you who follow astrology, the Sun is in the constellation of Sagittarius, and the black hole at the center of the galaxy is in the constellation of Sagittarius. They're millions of miles apart, but they're in the same direction. And this is what they mean by a galactic alignment. Viewed from the Earth, the Sun is lined up with the black hole, more or less, at the center of the galaxy. And it does happen around 21st of December. Now, I've made this huge scale so as you can see what's going on. What does it look like? A rather nice photograph of a little bit of Utah, USA, and behind it, the Milky Way. There's a band of stars like this across the sky. And that's because we live inside this thin plate that I've been talking about. And when we look out towards the rim of the plate, we see lots of stars. When we look in the other directions, we see very few. So we see a band of stars round the sky in the direction of the rim of our plate. And here is part of the band. It's the bit of the band that actually includes the center of the galaxy. Again, not showing very well. Here's Utah again, Milky Way behind it, and I've got a red line that marks the center line of the Milky Way. And the yellow disk represents the Sun. On the 21st of December, the Sun's position varies from year to year. So in year 1 it might be there, in about year 5 there, about year 10 there, because of a phenomenon called precession. And what the doommongers are saying is that on the 21st of December 2012, the Sun is not only lined up on this line, but is actually furthermore up there somewhere where the center of the galaxy is. The Sun crosses this line slowly. It doesn't all happen in a day. It crosses the plane of the galaxy over a number of years. It actually did the crossing in 1988. The process started in 1980 and it goes on till 2016. So on the 21st of December, between 1980 and 2016, a bit of the Sun falls on the Milky Way. But it moves very, very slowly, and it's also about 10 sun diameters away from the galactic center. So if something was going to happen, it should have happened on the mid-year 1988, the middle of this interval, or the effective middle of this interval. There's nothing special about 21st of December 2012. So, as they say in management terms, never waste a good crisis. You can buy things to do with 2012. You can buy some medals showing the Mayan calendar. You can buy t-shirts. Here's one showing, yay, it's coming. There's the Earth, there's an asteroid. This one says, let's get ready to rapture. Doomsday 2012. And perhaps more relevantly, you can buy gas masks or survival handbooks or water purification tablets to help you survive when the Earth falls into the black hole or whatever it's going to do. What's going on here? There's a lot of misinformation being put about. It often starts with a correct nugget of science, but that's then elaborated or twisted, A, to be scary, and B, to be wrong. Why? Why is anybody bothering to do this? Who benefits? I honestly don't know. Maybe you can see what's going on here. Is it some publicity-seeking individuals who get a great buzz out of scaring people? Or was it to sell the movie? Or to sell survival kits? I don't know. What I do find really scary is that a lot of us spend a lot of time trying to communicate science to the public, and the public, or some of the public, doesn't recognize that a lot of this is rubbish. That's really discouraging. There are a couple of useful websites if you want to learn a bit more reliable astronomy around 2012. And I thought this was a good way to finish. Thank you very much.